Well, surprise, surprise, another Miller and Kreisel, this time an MX-105 MkII. This time came with a note. The MX-105 subwoofer plate, amp, and transformer are enclosed. The amp functions well, low to medium volume, but when the main receiver volume is increased, the subwoofer distorts. The gain on the subamp must be turned to the lowest, -6 dB setting to help with distortion at high volume. This is not normal for this subwoofer. The bypass variable switch and the phase switch were bypassed because they went bad. If you think it's worth it to change them out and you have replacements, please do. Both 12-inch 4-ohm subwoofers are in excellent shape. Their voice coils read 4 ohms. This is from Victor. So let's go ahead and take a look at this thing. I'll hook up a speaker, not a 12-inch, but a 6-inch. I'll fire this up, put some audio into it, and see what it sounds like. So just taking a look around this thing, the resistors are very well mounted to the board. There's no slop and no play whatsoever. Maybe a little tiny bit on these little guys, but whoever was working this day did an excellent job securing these resistors down to the board. They barely move whatsoever. But what I see is these two main filter caps. The one says MX-105 and the other one, kind of hard to see, but I do see bulges on both of them. Let's see if the camera will actually focus on that so you guys can see it. Yes, definitely. Look at that. The tops should be absolutely flat. And these are ELNA caps, 10,000 at 50 volts. Now I don't have ELNAs as replacements. I have EPCOS from Mauser Electronics, 10,000 at 50. And if you look at the tops of these, there you go. They are perfectly flat. These are brand new caps I keep in stock just for this situation. So maybe we'll need them, maybe we won't. Let's go ahead and test it and find out. Okay, so I do have a couple of blocks of wood setting this up so it's not like falling over at a weird angle. But I do have it plugged into my Variac. Let's go ahead and power this thing on. I get a red LED indicator. I do have it going through my dummy load, so I'm not going to blow out my little 6-inch Infinity speakers. We'll hit play on the MP3 player. And I hear absolutely nothing at this point. Okay, I think we'll connect this directly. Okay, it is connected directly now. Oh yeah, that's bad. Okay, so to tell if this is 60 Hertz, what I'm going to do, well, first off, let's lower the AC input voltage and see if it gets much, much worse. Just power down. So I'm going to go ahead and hook up my signal generator and we'll push this thing into the point of clipping, or so-called clipping, and then we'll change the frequency on it and see if the clipping frequency changes. Okay, power is reapplied. I'm at 120-ish AC input volts right now, and I've got it set up to my signal generator. I'm going to crank this up. I'm at 60 Hertz right now, or thereabouts. You can hear the hum coming in. Let's increase the volume to the point of clipping. And you hear how the clipping is coming and going as the signal generator is in phase and out of phase of the incoming AC power. So listen to this. If I change the frequency on the generator just slightly, I'll turn it down to like 58 Hertz. There's 50 Hertz. Let's take it to 120 Hertz. You can hear it starting to distort. As I raise the frequency, so it's actually acting like a beat frequency oscillator, a BFO. So we'll go back down here to 60 Hertz. There's almost perfect 60 Hertz. And it's just fading in it should fade out momentarily. There's perfect. Everything's in phase right now. Now it's becoming out of phase once again. So let's go ahead and turn that back down. You don't need to hear that, do you? Unless you really want to. So let's go ahead and pull the board off this unit. Check those main filter caps. I'm betting either one or both are definitely bad. Now, we still could have another issue. We could have a bridge rectifier problem or a small filtering capacitor, because the small filter caps actually clean up the AC ripple off of the op amps, the preamplifiers for this unit. Okay, I got the board flipped up here, and I do have my blue ESR meter going, and I did zero out the leads, 0.00. And we'll go ahead and test these two main filter caps that live right here. Expecting to see probably an ohm or two. And I see 0.04, a little high. Oh, and 1.7. That is definitely the culprit right there. 1.7 ohms. I can probably live with the 0.04. I'd really like to see 0.01, maybe 0.02 at the most. And then these two caps right here are the filter caps that smooth the 12 volts into the op amps. 0.24, pretty good with 0.24, and 0.23. Those are both fine. But since I'm in it this far already, I'll probably go ahead and just recap the whole board just as a customer satisfaction issue. I really don't want these things to come back. Let's go ahead, and I'm opening my capacitor drawer right here. I'm going to get those two 10,000 at 50s out. I'll just kind of set them here off camera. Well, they're actually still on camera. And we'll go ahead and test them and see what they test like. I'd expect 01 or 00. Yes, perfect. Let's do lead integrity just to show you I'm not fudging the numbers. 00, 00. Once again, 00. And 01. Yeah, between 01 and 00. I'm perfectly happy with those. Much, much better than 1.7, 1.8 ohms. And this one is on its way out, 0.05 ohms. Toast for a 10,000 microfarad cap. I do not want to see more than maybe at the most 0.01, 0.02. So let's go ahead, and I'm going to have to fold this chip up. We'll just go ahead and change all the caps like I normally do on this thing. Just a cap refresh. Let me see if I can find a date on this thing. Well, according to the tag right here, November 26th of 01. So this thing is 21 years old. It can step up to the bar on its own right now. So let's go ahead and I'll mark all the negatives on these caps like I normally do. So there's going to be 5 large 100 microfarad at 63 volts. At least that's what I think they're going to be. This is just from past experience. Let's see if we can see any numbers on that. Yes, 100 at 63. And then there's going to be a 10, a 10, and a 10. And then I think there's going to be a couple of 1 microfarad, possibly bipolar. That one right there is a 10 microfarad 25 bipolar. And let's see if I can see the numbers on this one. 1 at 50 bipolar cap. Oh, I hope I have those. Oh, this is the 1 at 50 polarized cap. So I need to find a 10 at 25 bipolar and a 1 at 50 bipolar cap. Well, let's see what we can come up with. Well, this unit has 14 capacitors on the main board, and I have every single one. I have the 10,000s at 50, I have the 100s at 63, I do have the 1 at 50, and the 3 10s at 63, and the 2 1s at 50 bipolar caps, but I do not have any of the 10s at 25 bipolar. So we're going to take a couple of 22s and we're going to put them back to back, either negative to negative or positive to positive, to make a 10, actually an 11 microfarad bipolar capacitor to use in its place. I've been doing it for probably 30 plus years, never had an issue. It works perfectly fine. So let's go ahead and get these caps installed and get this thing back on the road and give it a final test. And we'll go ahead and test the bipolar cap that I made from two 22 microfarad caps. And it tests 12.3 microfarads. Perfectly happy with that. 0.81 ohms ESR. Excellent. So let's go ahead and test the new filter caps in circuit. I should see 0.01 or 0.00. Perfect. 0.01, 0.00, absolutely perfect. We'll go and test a couple of these little caps just to make sure they're okay. 0.12, perfectly happy. And 0.12, perfectly fine. I trust all the other caps are good. Here's the 10, actually 12 that I made. 0.8 ohms, very happy with that. And I think this thing is going to be good to go. Let's go ahead and throw this thing back together now. Remember, when you reassemble this fiber washer goes in between the STK chip and the circuit board. This goes on top of the board, fiber washer, STK chip, then to the heatsink, and then into the final heatsink down here, which I did tape on with a couple pieces of tape so it didn't move. Well, I definitely did a whoopsie doodle and installed this capacitor right here backwards, but I did correct it off camera, so everything is good. Heatsink remounted, all the caps have been placed correctly. I did double check all the polarities of these caps. Everything looks perfect. I did make notes, bipolar 1, bipolar 1, this is the 1, and this is the bipolar 10. Well, it's 12 now, but that's within tolerance, definitely. So let's go ahead and add some RTV to all these caps to hold them down. We'll retension that Molex connector. Put a couple beads around the main filter cap so they don't vibrate with the bass. These things do have nice, heavy bass. So let's go ahead and add a little Deoxit F5 to these pots real quick. Since we're here, why not? And since the customer mentioned that he bypassed these switches, let's go ahead and test them and see if they're actually defective or not. Oh, I'm going to say yes, they are definitely defective. That one is definitely bad. Let's test the other terminal of that switch. Yeah, that thing is toast. Let's verify lead integrity. Just short them together and we get 1 ohm, perfectly fine. Now to the other switch. If I can keep them touching together. Yeah, barely touching the switch and it's bouncing all over the place. Let's go and test the other lead here. Oh, not even getting anything at all. Lead integrity once again. Yep, perfectly fine. So yes, the customer was correct. The switches are bad. So I can probably find some replacements, but he seems to be pretty happy with just the leads kind of shorted together here under tape. I'm just going to leave them be as is. And once again, we'll go ahead and add a bit of pre-tension to the Molex connector right here. Just with a screwdriver, bend these pins in ever so slightly. They will round out once you push them back together, and it's going to get a great connection to the circuit board. Don't worry if you go too terribly far, it'll be just fine. All right, those are good. Let's do the 1 pin left on the board now. Okay, good to go. Let's throw this thing back together and give it a final test. Okay, signal generator reconnected, power on. Let's go ahead and turn up the gain a little bit. Way better than before. Because I couldn't turn this up more than about there before we started to get distortion. So let's crank this thing up. Keep in mind, no dummy load at this point. Change the frequency. No distortion at all. I'm down to 10 hertz right now. What you're hearing is the actual speaker thumping right there. It's pushing the speaker so the voice coil actually contacts the magnet. Yeah. Working much, much better. Okay, so I thought I'd show you this real quick. This is how much energy was being dispersed into the voice coil. I could actually smell the voice coil to begin to burn. The enamel was burning off the voice coil. It was so hot. So this is the speaker that was being driven compared to one down here. Okay, audio is connected through the MP3 player. Regular audio playing. Well, speaker still sounds okay. A lot of bass now, a lot of bass with no distortion. Anyhow, I think that's going to be it. The repair on the Miller & Kreisel MX-105. Now, I'm not going to actually film this, but I'm just showing you the temperatures on the heat sink. So we're at 92 degrees. It's working absolutely perfectly. I certainly hope you enjoyed the video on the repair on the MX-105 MkII. Go ahead and leave me a question, a comment, a concern down below, good or bad. I try to respond to the comments when I have time. While you're down there, I would really appreciate if you hit that subscribe button and like this video. It really does help my channel grow. You can follow me on social media, Facebook, Instagram, Twitter at NorCal715. You can email me norcal715videos@gmail.com. That is the best way to contact me. Please be patient. I have a full-time job and I do these repairs in my spare time. If you try to contact me on Facebook, Instagram, or Twitter, please be aware it might be weeks or even months before I respond. I rarely check those messages. Please, if you want to contact me, use the Gmail address only and be patient. Remember, with your help, we can try to keep these things out of the landfill, out of the recycle bin, and out of the e-waste facility. Everyone, thank you so much for making it to the end of this video. I really do appreciate it. Everyone, have a great day. Once again, thank you so much for watching. Bye-bye.